When it concerns learning about the past, there exist presently no options for time travel, so researchers have to depend on our ability to assemble the clues that were left for us in the present. Almost all areas of our world contain such clues, if only you recognize what you were looking for. From studying the construction of old Egyptian pyramids to forming a picture of the early days of our universe, there is no limit to the puzzles that may be unraveled. So today, here at Unexplained Mysteries, we will examine 3 recent discoveries and what they signal for our understanding of the past. 1. Cosmic particles in Egypt's bent pyramid examined for clues. It appears that the vestiges of mummies and the hidden riches of the rulers of Old Egypt are not the only things lying among the ghosts inside the Egyptian pyramids. A latest announcement issued by a multinational team of researchers with the Heritage Innovation Preservation Institute stated they plan to carry out analysis on cosmic particles gathered inside the Bent Pyramid, one of Egypt's best-known ancient structures that was built around 4,600 years ago. They hope this data will offer useful information about how the Bent Pyramid was built, to validate one of several theories regarding how it was ultimately raised. Quick pause here. If this story's grabbing your interest, tap like and subscribe. It really helps me keep bringing you these tales. This study aimed to measure muons, which are a kind of subatomic radiographic particle that resemble a far heavier electron. Plates were positioned within the bent pyramid to capture these particles, which traverse empty space but are absorbed and deflected by denser surfaces. The muon buildup on these plates should enable researchers to examine the thermal anomalies that the Scan Pyramids project reported within the Bent Pyramid earlier this year, and to reveal some of the persistent construction mysteries surrounding the pyramid. The Bent Pyramid, so named because of its distinctive sloping sides, stands out as a transitional experiment in pyramid design. Researchers suggest it might have been one of the earliest attempts at erecting a smooth-sided pyramid. Built by Pharaoh Snefru around 2600 BC and situated within the royal necropolis of Dashur. As a model marking the transition between step-sided and smooth-sided pyramids, insight about the technicalities behind its construction can potentially illuminate both styles of pyramids. For example, some think that early Egyptian builders, trying steep, smooth sides with little precedent, observed the upper angle rendered the structure unstable and lowered the angle partway up to avoid collapse, resulting in the pyramid's trademark bent appearance. It is hoped that analysis combining thermal technology with muon detection will provide archaeologists and researchers clues as to how the pyramid was assembled. Knowledge that would be particularly meaningful given the bent pyramid's transitional features. Hani Halal, the vice president of the Heritage Innovation Preservation Institute, stressed that regarding the construction of the pyramids, there exists no sole theory that is 100% proven. They remain theories and hypotheses. What we aim to do with the new technology is either confirm, alter, refine, or adjust the hypotheses that we hold on how the pyramids were constructed, he said. How the magnificent old Egyptian pyramids were raised to such colossal proportions despite lacking modern tools remains one of history's lingering mysteries. Hopefully, the analysis of these cosmic particles will illuminate construction secrets that have been preserved for thousands of years. 2. Earliest stardust ever detected. Dust observed in a distant galaxy. Dust has long served as a revealer of secrets, revealing who has failed to polish their trinkets or how long something has lain untouched. But astronomers can also use dust in a cosmic sense. Dust formed and scattered after explosions caused by short-lived supernovae. The early universe teemed with these explosions, and lately astronomers may have detected some of the first stardust ever created in a remote galaxy. The dust was detected in galaxy A2744YD4 at a time when the universe was only about 600 million years old, by researchers examining the location through the Atacama Large Millimeter/Submillimeter Array, ALMA. Although 600 million years sounds ancient, In the context of cosmic history, it's a blink of an eye, a period when supernovae from some of the earliest stars were already unfolding. Finding dust from early supernova explosions is an exciting discovery. Mikhail Mikhailovsky, an astrophysicist with the University of Edinburgh, voiced his excitement. Dust is widespread in nearby and farther galaxies, but has until recently been extremely hard to detect in the very early universe. This paper reports the most distant galaxy in which dust has been detected. The dust was detected by Nicholas Laporte and colleagues at University College London, and their report suggests we are likely observing the universe's first stardust. Uncovering such an early example of stardust is significant for how scientists interpret and investigate the origins of our cosmos. Upon analysis, Laporte and his colleagues found that the supernova dust was ionized with a positive charge, indicating that the gas from the galaxy itself is likewise ionized. Researchers propose that ionization enabled the structures of the universe to start emerging, as particles no longer interacted in purely neutral ways. This switch from neutral atoms to ionized particles is termed reionization. Mikhailovsky proposed that the discovery of ionized particles provides evidence that at least a fraction of cosmic reionization was caused by galaxies like A2744 YD4. Essentially, this discovery places a marker on the timeline of early galaxy formation that appears to corroborate present hypotheses about ionization-driven changes in the early cosmos. While previous studies of early galaxies were often limited to counting numbers, sizes, and colors, complex analysis of dust can now offer a more quantitative look at the mechanics behind formation. Examining dust composition and the abundances of oxygen, silicon, and other heavier elements can also help date galaxies, since fewer heavy elements typically indicate younger systems. This discovery is a major clue for future studies into how the universe formed. 3. Cataclysmic collision with the Sausage Galaxy altered the Milky Way. As far as galaxies go, the Milky Way looks oddly shaped, an inner bulge and an outer halo that forms a ring-like structure. Scientists have long debated why it appears this way, and a recent hypothesis may supply answers. A group of international researchers proposes the Milky Way was forever altered by a chaotic collision with a much smaller dwarf galaxy between 8 and 10 billion years ago. That smaller, sausage-shaped dwarf galaxy was effectively destroyed by its crash with our much larger galaxy, erasing it as an independent system. But the dwarf stars remained, scattered in the region, and left moving in very radial, needle-like orbits near the center of our galaxy. Vasily Belakurov of the University of Cambridge and the Center for Computational Astrophysics at the Flatiron Institute explained that the collision ripped the dwarf to shreds, leaving its stars on highly eccentric orbits. When researchers reconstructed the paths of these stars, the figure of the original dwarf galaxy emerged for the first time, revealing a distinctive sausage shape, hence the nickname Gaia sausage. Galaxy collisions are common across the universe, but tracking past encounters of our own Milky Way helps us understand how it came to look and behave as it does today. The discovery of this sausage galaxy is important because it provides a clearer picture of the Milky Way's unusual structure and its violent formative history. Remnants like these are crucial clues that allow researchers to reconstruct long-past events that we cannot observe directly. There is no way to travel through time to observe what happened as the universe formed. Finding remnants from long-ago activities, whether in stones, stardust, or stellar orbits, remains essential to reconstructing our cosmic and cultural past. What do you think of these discoveries? Share your thoughts in the comments below and help expand this community while we strive to unravel more unexplained mysteries. Thanks for watching, and remember to subscribe for more videos. Thank you for treading this trail of tales till we travel together again on another adventure.